So, has everybody seen The Truman Show? Yes? Okay, good movie. So, the premise of the movie is Jim Carrey, he's in a reality show. He doesn't know it, but he's in a reality show, right? Everything around him is staged, right? So, and I'm going to try and relate. So, that was a good analogy for me to understand what was going on with containers, right? So, hopefully I can like convince you guys that that is a good analogy and not I just didn't make this thing up to make you guys show up here.
I've never seen the Truman Show, but I Googled it. I'm
What?
gonna watch it when I go.
You should. You will thank me. All right. So I think one of the questions was are containers virtualization, right? This is also the slides are from like the summer. I did this presentation a little while ago, so the memes might be outdated. I've tried to keep it funny, so it's not like a normal presentation. It does get boring at the end when I get to the tech stuff. So our containers virtualization is Docker virtualization. What is Docker? What is containers? Like, is it virtualization? Nope. Containers, the term that we use, they're just processes, right? Like if you run a process on a Linux machine, that's a process. That container is also a process. There is no virtualization in there involved. So you get like raw machine speed, right? So what makes it special? Or because it thinks that it's special. It's really not special. It's just a plain old Linux process, but it thinks it's special. Why does it think it's special? Because it's all staged, like in the Truman Show. We stage everything around it, like all its environments, to trick it into believing that it is root on the or that process has root or its UID is 0. So that's all containers are all about. It's just Linux processes that thinks that it's special. What? Under the hood, it's all duct tape. If you go back from when Docker actually came about, and that wasn't like 5 years ago. It was barely. They had a very good functioning prototype and everything, but they had just put it together, right? So Linux had all these concepts that had existed for a while, but nobody ever thought of putting them together, and Docker did, and now they're being funded in millions, not in the billions, I think, but in the millions at least. So it is just Linux system calls and Linux APIs being cleverly used by, or you could even say it's just clever bash, right? So, but yeah, it is a little more awesome, not just like duct tape, but it looks good. And Docker is not container. Docker is a company. And containers are Linux processes that think they're special. Docker, the command that you run, I think of that as like a UI. So right, so Docker took containers, which was very hard to do before. It took it to the next level, right? So Docker really made containers happen, right? Containers existed before, but Docker really made containers happen. And really, Docker is just a front end. It's got like a lot of pieces. So when the command that you run, Docker, I think of that as a UI. Because that's all it is. It is like it's a user interface to creating all these special processes that think they're special, right? And so the docker.exe or whatever, the command that you run it's the UI. And on your machine, if you got Docker installed, like I do here, I'm not going to open up terminals and start typing, which I can but I don't want to. So you'll see that there is a Docker daemon running that's called like Docker D. That's always running on your machine. So this client program, Docker, is talking to Docker D over HTTP or Unix sockets or TCP, because the Docker daemon that is actually running, the engine that is actually running the containers need not be on your machine. I can just run docker.exe, the UI, on my machine, but I could be talking to a Docker daemon that is running on a central server somewhere, right? So it's just basically, in that case, no resources on my machine is being used. I can create Docker containers or containers all I want, but it's running on some remote machine. And you can get Docker-like functionality in around 100 lines of bash. And it's, if you just Google this, or did I make it a link? No, I didn't. Well, you Google this and you'll find it, right? It is, you can build 95% Docker in 100 lines of bash, and they got millions of dollars for it. Well, they were first to do it, and it's good because before that, there was a lot of pain. So, and it's like a lipstick on a peg, right? Containers, old thing, you just put a lipstick on a peg and we made it happen. So Docker is kind of like, I think think of it as like a controller, but Docker's not the only one. So Docker, and Phil Estes, I think he is leading the Docker Container D project. He's in Charlottesville. He gave a talk in November. That was awesome because a lot of this information is hard to come about, and I was there and I was asking him a whole bunch of questions. So I found out things that it's hard to find online, especially since things are changing so fast. So there are a lot of things that will help you like start containers and run them, not just Docker. Docker is one UI. LXC, that's written by the Canonical guys who make Ubuntu. That's also like a UI that'll also create like these special Linux processes. Rocket, VZCTL, I'll get to that later. And systemd's got a systemd nspan, and systemd nspan is just 200 lines of C. So you can see it is very simple, just almost glue code, just taking one thing and putting it into the other, and a lot of it. But there's a lot of gotchas, so that's why they get paid that much, because they work with legacy. I like to think that they work with the Linux legacy code and they know every little bit about it, like what's going to go wrong. So that's why they get paid millions. So yeah, Docker is, I already talked about that, but how does it all work? So one of the main things that make containers possible in Linux, there are some concepts that make containers happen. It's namespaces. And I also got like terrible jokes. Could you guys tell? It's a space for your name, so it's namespace. So yeah, so if you don't like the talk, you probably like the bad jokes. And it's got a supporting cast too, called like chroot, where we'll get to all these things later, but just now you just know the terms: chroot, namespaces, and cgroups, right? So okay, how did all this thing happen? How did we get to it? So in 1998, FreeBSD had jail. So chroot existed in like this. I want to say the 70s or 80s, but yeah, I think it's in the 70s, where chroot, where it'll make any directory, it'll make it look like root on your system, right? So why did this come about? Like, did they know that containers were going to happen like 30 years ago? No. One of the guys working on Linux or Unix at that time, he wanted to do integration testing, and it was a pain for him to do this, right? So he just came up with this chroot, and now we are using this 30 years later to build this concept of containers in Docker. So it existed, came up in 98 in FreeBSD. I'm going to go through this really fast. 2001, a company called Virtuoso. Now I think they bought out by a company called Parallels. They basically make like, what are they? Like virtual box kind of things to run VMs on your machine. And those are the guys who did this, right? So without them, and I think they're a Russian company, and they did this in 2001. They forked off, they came up with the concept of, it wasn't a Linux thing. So Virtuoso guys, they did it. And then in 2004, Solaris had the concept of zones. They even had a container kind of concept for Windows in 2004, right? So in 2005 is when they released it as, like Virtuoso guys released it as OpenVZ, where they had the concept of like namespaces. So not Linux, they upstreamed it, as I'll talk about it later. And then UBC is like user bean control. That's like what, that got replaced by cgroups now, but that was what they had come up with for cgroups. So things like, wasn't all like, No genius sat in a room and came up with containers or Docker. It all just happened because people are working on different things. And VZ-Cota, like, restricted memory restrictions, and VZCTL is the command line UI thing. And it's still alive, right? Some people say it's still the best way to run most secure way to run containers, right? 2007, cgroups were upstreamed by Google and IBM. That wasn't from the Virtuoso guys or now the Parallels guys. And 2008 is when OpenVZ upstream namespaces into the Linux kernel. I think they work off of Red Hat. 2008, the same year, I think Ubuntu came out with LXC. It's their own way to like create, and they are updating it really, really fast every year. And some of the features in LXC is like really awesome. It's soon enough, we might not remember Docker. In 2003 is when Docker came about. In 2003 is Google also. They've been using it, but that's like LMCTFY, let me container that for you. That's what they used to call it. 2013, user namespaces. Before this, every process was like running as root, and so 2013 is when user namespaces landed in Linux kernel, and it only came to Docker in 2016. And 2015, OpenVZ dumps UBC for the cgroups that was upstreamed by Google and IBM. And Docker, whenever you used to run 2009, 10, that area, whenever you used to run Docker, it used to call LXC to make magic happen, right? That's the glue. Docker provided us the glue. So Docker used to use LXC. Now they got loop container and container D, which is what Phyllis has talked about. Yeah, and so I hope this works. Okay, what am I doing? Can you guys see that? So I'm just kind of showing that the Docker daemon is running, and container D is also running on my Linux box right there. So, yep. So you can see that it's running as 719, right? Ooh, lost context. Like, if anybody has any questions, feel free to stop me and shout out, because you're gonna get sick and tired of hearing me. Okay. And Docker daemon still needs root. So you guys can see that here. That whenever I grab the PS output, and it's the user, you'll see that it's still running as root. And container D, if you had noticed, somebody had noticed, it was also running as root on the host machine, right? Okay. So and then OCI came about. So Docker became like caught on fire, and everybody was using it, and Rocket was doing its own thing, and Docker were doing its own thing. So they came up with like a standard for OCI. This is for the image, right? So when I said containers are just processes, it is true, but this process might access some files on disk, right? So we need to give it those files on disk that it needs or is looking for. So, or this could be like the canonical distribution of Linux or whatever, right? So any kind of Unix distribution, we just package them up into like OCI spec containers, and I have more about this here. So we got the running process, and also we got like the image, which is what is a Docker image? What is an image? It's nothing but a config.json file and a tar gzip tar file. And the gzip tar file has like all the files that come along with your Ubuntu distribution or your Red Hat distribution or whatever. So here, I am trying.
Is it possible to zoom in a little bit on that?
Okay, sure.
Can you actually zoom in?
All right, I'm gonna try. Yeah, this is recorded. This is not a video. It's recorded in ASCII Cinema, so not sure if that's gonna work. I'm gonna try. Ah, it does work. Although, even though I'm on a Mac, and this is a VM, so that was, yeah. All right, so I'm gonna try and start it again. Oops. So here I'm saving that Alpine image from Docker. I'm saving it into a tar file. So Docker's got a command called docker save Alpine. So I just piped that output to a tar file, and boom, I got a tar file. Now I can untar it. I'm going to create a directory called Alpine, and I'm going to untar it, and you can look at what's in it, right? And you'll see that whatever is in it, it's just a JSON and some like files that the layer.tar files that Todd had talked about. You got like layers in there, but it's nothing fancy. It's just a tar file.
So what is a layer?
Okay, so I will. I'll talk about it after this is done. Right? Is that it? Oh. Okay. I think that is it. Oh, okay. You can see how slow I type. So this is the contents of the config.json file, right? Okay. What is a layer? So so Docker images, or it needs these files, right? But creating them every time can get like time consuming. So what they did was they wanted to like make it incremental, right? It doesn't need to be. So they wanted to make it incremental. So you got the base Ubuntu distribution, you install something on there. So the base Ubuntu distribution is a layer. So whatever you install is going to add new files, and that's going to sit in another layer. All these things are just files, like tar files, and then Docker just unzips them, and then there are file system drivers called. It used to use AUFS file system. It's called the Union file system. So it's going to take all these directories, almost like do a union on them and make them look like it's all one thing. And now if you run Docker, it uses like the overlay 2 file system. So layers, everything's just simple tar files with files in them. Any other questions?
So when you build a layer, can you first like you build one layer and then use that as a base, like you have a base image, and then you can build another layer, say for instance drivers or something like that. Can you separate that where you can just use that drivers layer with another type of
Yeah,
image? So
yeah.
just stack it all
As long as you know what you're doing and you don't screw up the files that the image, yeah, you can do all that. So Docker file is just, I got content on that later. I don't know how much time I'll be able to spend on it. The Docker file is just one way of creating your images, right? And some of the examples that Todd looked at, you saw these like run, every line in the Docker file creates like a new layer. Do you really need it? Yeah. So every step in a Docker file creates its own layer, right? And that's why if you look at most Docker files, there will be a lot of apt-get install this and apt-get install that, and so they all want it to be in one layer. So they just make that command like obscenely long. We are in 2018 and we still doing this, but it doesn't need to be, right? So that's the Docker way, and actually Docker is working on something called BuildKit, which I don't know too much about. That's making that better. But Red Hat, or should I say IBM now? Red Hat has a tool called Builda, Bulda, h, and I got links to it here. So the way you can do the way it works is like, hey, here's my directory first. I got some things in there, and then you can apt-get install anything you want. You can add any file you want. You can apt-get install into that directory, local installs into that directory. You can run 1,000 things if you want, right? And then you can say build a commit. So you get to dictate when that layer gets stopped, right? Dockerfile's like, Vish is too dumb to know all this. I'm just gonna give him like one step is one layer. But I can control layers. We can control layers. We can make layers. It's just files on disk. It's not magic. Yeah. So what it does it just does some fancy hashing to see if the Docker file changed, and then if you changed one line after the image has been computed already, it's going to say, okay, Vish didn't mess with this line. Vish didn't mess with this line. Oh yeah, he's messed with this one. So I gotta invalidate all the other layers that had those things, and then it's going to reuse the ones that I did not mess with, and then it's going to like try and rebuild only the things after. So everything after, I could have just changed one line, but it don't matter. It's going to try and like it's going to rebuild all the other things, commands underneath that. So be careful when you're changing Docker files. It's not really a good user experience. You know, we gotta have better tools than that, and I'm happy tools like Builder exist, and there are other tools like IMG and things that can run rootless and do all these things, and Podman. So yeah. So does that answer your question? Go ahead.
What's the hash? Is it like SHA-56, SHA-1? I mean, or is it their own proprietary?
Yeah. Are you interested in what hash? Yeah. Are you interested in what hash? Because all they're doing is to check. I don't think it really matters. And, well, it might. Yeah. It's not for me to say because it's like you're just checking that nothing changed, right? Yeah. It is. Yeah. 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 Like, it works. So that Docker config JSON that you guys saw, right? It's got like all that information in it. You can think of that as you don't really need like it's just a way to like store all your Docker command line parameters. You can think of it that way if it's a little easier. So normally you can set like the host name and what user to run as and what's the root and everything in that config JSON. You can specify those same things at the command line too. And that's going to override what's in the thing. I think we'll be looking at some config JSON things later, but JSON, it just like contains metadata about. So whenever this container is like running, so the config JSON contains information like so like I told you, I can fake it. I can fake the container into thinking, hey, your root is different. Your root is this directory, right? That information that I need to give it, and I can show you some of those. That hey, this is the root directory. That's going to be in the config JSON. So let me pull one up, just because you asked. Okay, so I got a config JSON right here. So I'm gonna do. I'll bat it out. Oh, Okay. Uh, I just made this VM just for this presentation, so I'm not. You might see me struggle. Huh? Edit. There's a zoom in. Ah, there you go. Damn it. Ah. See, I'm on a Mac, so I hit Control Command. All right. No, that is not working. Okay. Good. So this here basically tells you, hey, should this thing have an interactive terminal? Yes, true. User GUID, what user should I be running as in the container, or what user should I fake the process into believing that it is? I can give it that. Args is basically what program to run in the container that I'm here. It's just running the shell. And environment, you can pass in environment variables, and you can also pass it in through like Docker -env and then specify all this. But who wants to type that in all the time, right? So it's in here, and there are things called capabilities. So that is one of the security mechanisms that are built in. Capabilities is it's a Linux concept where even if you're root, right? If you don't have certain capabilities, like so if you're root, you have like cap sysadmin, right? So so I can restrict what capabilities that you can use, and if that process tries to do something that these capabilities do not allow, it's going to put the kibosh on that, right? And then there is a seccomp too it can use, and you can actually specify what I'm not too familiar with where it is it is somewhere in here. It may not be this config JSON, but I know you can specify what syscalls, Linux syscalls, that container process is allowed to make. So that's how you lock it down. So if somebody's running, whenever say, oh, Red Hat or ACS or Amazon is running my container for me, it's like, and it's running like your container right next to mine. It's like, that sounds weird, right? They can just like talk to each other or So that's how it locks it down. So yeah, so that's a security mechanism in seccomp. So all these things are in here, and it has like the host name. What is the machine? What does the process think the machine name is? So you can specify all these. There is probably going to be like, hey, where is your root? Yeah, host ID. So you are 0 in the container, and the host you are 1000, user 1000, right? You can configure those mappings there, and it's specifying all the namespaces that it's going to use. We'll look at the list of the namespaces later. That's kind of it. And somewhere in here, there should be a rootfs. There was where did I pass it?
Yeah.
So rootfs is right there, root. I'm specifying it. Hey, this and you'll see here that I got a directory called rootfs. So whenever I run that container, it's going to think that directory rootfs is its root. That's not the case. Oh, well, for it thinks it is. So. Anything else? All right. Yeah. It's a process. You can start a container in. So it is. So when you say. Did I tell you to ask that question? Because we're going to cover that later. Yes, I will show how to do exactly what you're asking coming up. So there are Linux tools just for this. So run C. Run C is like It comes out of the OCI, the spec guy. So they build. I think it's built on top of a lib container. It is. Although things change so fast, I don't know. So what it is it's a runtime or implementation of the OCI spec, right? Of the container spec, right? And it can run rootless. It can run. Oh, where I lost my. So if you look at and this I found this out because I came to the talk for Phyllis test, right? So it is so complicated, and so whenever you run like Docker, the UI, the Docker command UI, it's talking to the Docker daemon over like Unix sockets or like TCP or whatever, and then the Docker daemon talks to container D over gRPC, and container D in turn uses this thing called runc to actually like create like namespaces and things that I'll talk about, and then it'll like, yeah, you did what I wanted, now you go away, I'll jump in that spot, right? So it's gonna do that, but you know what? We can run C ourselves, and this is how you do it. Too big? Okay. Wow, I type slow. Did I start it? No, I think I made it too big. Yeah. Done it. Okay, sorry guys. I like ASCII Cinema, but I should have captured less of my screen. So here I'm creating a directory called my container, jumping into it, creating a directory called rootfs that is going to be like the root of my container, not Docker container, and I'm going to like do an export. So last time you guys saw save just gets the image into a tar file. Export actually takes a container, right? So running container might have some state. So even when containers stop, the state is still around until like you go clear it. So you can go get them. So I can go export that state out, and then I can get them into like a file system. So here's it exported all this stuff out into rootfs. And what is in there? It's these, what you will find at the root of your Linux box, right? So that's what was inside that container, or that the running container. So I just said run spec. Run spec, it's like a scaffolding thing that like creates like automatically creates like the config.json file that you guys saw. It just creates like a thing that you can go easily edit. So instead of creating this stuff, and that's what I showed you guys before. So it gave me run spec, just gave me my config file, and like since I exported that container out onto the file system, now I got my files that I need, and I got my config JSON that's going to tell the container how to run. So now I'm going to say runc run, and then I'm going to give this can be any name. I can give it like, oh, run, it's going to pick up the config JSON where it is, and it's going to say, hey, you can't do that because you need to be root. But I told you runc can be rootless. I think I'm going to be doing that later, where I can run runc spec and say -- rootless, where it'll actually tell me it. Oh. Okay, so I just did. So I did a sudo run contain me, and I went in and I got out, and I removed the existing config JSON. I'm running the runc spec and say rootless. Now it's going to create me a different config.json with the right settings that'll let me run rootless. And now this is, it's not much difference, but you can see that the UID mappings will be in here, where the things that you saw with the 1000 to the 0 to the 1000. And when I will be able to run this, I can say run C run, and I'll be able to run it without root or without sudoing it. And here, I think, did I? User name, the namespaces should also contain a user namespace. I don't know if I'm showing that. I did not. Nah. Didn't think of that.
So for the user ID, you were mentioning about 1000 and some kind of IDs, right?
Yeah.
How do you define an ID for the specific username?
Okay, so there's, if you you do that with like something called a sub UID and sub GUID or GID. I'll get to it.
Is it like an inbuilt to Linux?
What?
The sub UID?
No, that's what came in the user namespaces when they were introduced to Linux in 2013. That's what they did. It's I think it is done. So the way you generally do UIDs is, let's see. There are commands, but I can show you ls proc self, and then there is a UID map, and there should be a UID, yeah, UID map and a GID map. Yep. Let me see. Oh, what am I? Oh. No, not that. That's not what I wanted. Let's see. So you can edit it there, or there are some commands that you can use to do it. I think I should be able to cat it out. Yep. So this means that this user 0 has the user or the mapping range of 0, and then the starting from 0, the first one is the user, and the second 0 is the starting index or starting number, and the next third number is the length of how many UID things that it can take up. So that's how you can configure. And there should be some tools which I.
I have a question. What is the use case for that root list thing? Why would you do that? What do you do with that?
Security purposes, I guess?
Oh, to make it so that it can't run as root on your host?
No. So one of the things, like whenever you run Docker container, and if you run like the PS on it and go look at the thing, you'll see that that container process is running, the user is root, right? And when I did this, it's not running as root. It's running as the user 1000.
But user 1000 inside the container, right?
No, it runs as user 1000 in the host, because I've mapped 0 to 1000. Inside the container still thinks that it's root, because I set the UID to 0.
So you're making sure that you're decreasing the attack surface on the
Yeah.
host system?
Yeah. So it's really that, and that is one of the main things that'll also to create all the other namespaces, you need root. To create a user namespace, you don't need root.
So does this give you ability, for instance, you have 50 developers on the box, as opposed to admin having to start and stop all these Docker instances, the individuals can do that because they're already rootless?
Yeah, that is exactly, yeah, that is exactly why these things are happening, because universities they don't want to give root to anybody, and all these a lot of this stuff I think it was coming out from like OpenSUSE or something, where they're like, oh, I need to run this as and that's exactly where it's coming from. And also, why run as root? Like, that is something that Unix or Linux people don't like. So questions? So here are some of the tools that are useful. I'll just go over them briefly. Scopio, it is like, all these tools, are trying to put Docker out of business, which is a good thing, or at least competing. Scopio helps you like inspect images without downloading them remotely, and it can like talk to any kind of image registry and things like that. You can get it from one registry and send it to another without like doing all sorts of clunky stuff like storing it and then pushing it out. Builder is what I talked about, where you can like say build images, and Builder can run rootless. To run Docker build, you need to be root. Builder, I can be any user. I can build a container and I can run it. IMG is another thing that can actually parse Docker files, but it doesn't need root to run. So they're just trying to put Docker out of business, right? And Podman is really a Docker replacement from Red Hat. I think Philista has even mentioned it. So you can alias a lot of people like alias Podman or Docker to Podman. So they're just running Podman. They don't even know that they're running like something else that runs rootless. And Podman can run rootless. Okay, so stuff like what is this? The namespace. What do we talk about? So namespaces provide isolation. So the things that are used are namespaces, cgroups, chroots, and those are the like main three things that are used to make containers. So isolation, namespaces, what do they provide? They provide namespaces provide isolation. And what are the namespaces? You got like a cgroup namespace, a mount namespace, a UTS namespace, PID, IPC, user, network. Cgroup is for like controlling what your process can or cannot do, and I'll get to it later. Mount is like what are the mounts that you have available on your system. UTS is your like a host name and domain name. Network is your network. You get a new virtual adapter and like new set of IP tables and everything. You got to do it. PID is a process name, like your process tree. You get a brand new process tree, that isolated process tree. IPC is inter-process communication. I'm not really used it, or I can see, but I didn't dig into it. User is what we talked about, like you're this here, but you're that there. LSNS. So what do these things like actually look like? Let's just talk. Ooh, okay. Readable. All right, so LSNS is a tool that will list the namespaces that is available to the current user that is running. So these are the namespaces that are running. The PID that you see there, it might be like misleading. The PID there is like the lowest process ID number that is sitting inside the namespace. So that LSNS listed all the namespaces that are available to me. I picked the current, like the $$ is the shell's PID. So LSNS with the process ID of the current shell, and I see those are the 7 namespaces that we talked about, and that's right there. And the PID looks different because that is the lowest process ID in that namespace. And you can see that number right there. Whenever I go do a LSLI on that process, in the process tree, you can see the inode number. So these things, they don't have names, so they use like the inode number. So those are the inode numbers. And you can use them other places, and I'll show you other uses for them, or how you can use these things. Okay.
Now, are you using it inside the container?
No, outside on the host. I'm just saying, hey, what are the namespaces that it like showed me? Like everything is in a namespace, whether you like it or not. It's in the default namespace, but okay. So unshare. Unshare is the tool that you can use to run a process in a different namespace, right? So you can pick which different namespace that you want to start that process in, and it'll let you do that. So I got some like commands for this. So I say host name here, and it's like, oh, my host name is like osboxes. Now I say unshare, and take me out of this, unshare me from the -u is the UTS namespace. And like I said, that was the host name and the domain name. That's what that isolates. So now I got a bash. I said unshare, run bash with unshared user namespace. and I look at what's the host name. It says host name. Now I say, okay, change it to pizza. Now I say host name. It's coming back as pizza. Now when I get out of here, I say host name. We're back. So just in that process, right? So I just ran a process in a different namespace. Right? That makes sense. And then the next one kind of relates to your question.
So does this also mean when we deploy a container, it creates one process in each namespaces?
Yeah, like process will sit inside namespaces, and yeah, not one process. The same process will be in one of in every, like it'll have a PID namespace. It'll be inside, or not inside. Inside is it'll belong to a PID namespace. It'll belong to a UTS namespace. It'll belong to like a net namespace kind of thing. I had other unshared things. I can show that if you guys are interested. So this is nsenter. Nsenter, by doing this, I can like unshare, creates that process, and once I exit, that other thing is like gone, right? That other namespace that I had created is gone. So what I'm doing here is I'm like creating a file called utsns, and I'm saying, hey, unshare, and then I'm saying dash dash uts, and giving that file. So that namespace has been linked to that file. The inode is that the file's inode, right? So now that thing is still around because that file is still around. Now I'm using nsenter to enter into that UTS namespace that other process left behind, and and I'm in there, and you can see that I got like my host name is that namespace where I changed it to pizza is still around. Does that make sense? Okay. So I think here I am showing, hey, I can even like I'm finding out what is the shell, what is the, whenever I run a Docker container, I'm finding out like the process ID for that, and I'm jumping into that container's namespace, and I'm messing with the, yeah. So here I run the Alpine container, and I know that's that. So I'm trying to find out, okay, what is this container's ID? I'm just trying to find out, hey, show me all the container D things, because it should be a root process of the container D. I can see that the container D's process ID is 719. So I do a PS tree on it, showing the process ID numbers, and I can see that sleep is right there, and its process ID is 6923. So I'm going to now enter into that namespace. Now I'm going to enter into that namespace. So I'm going to say my target PID is that containers namespace, and the namespace I want to get into is the UTS. And I'm going to run bash on it, even though bash is not in that Alpine. It's only got sh. So now I'm on it. Now I'm running hostname, and I see that the hostname is the container's hostname. Maybe you guys might be interested in unshare. I don't know. So here I'm just changing my user, creating like a new user namespace to change who I am. So who I am, I'm OS boxes. I do unshare. The map root user is like, hey, make me root, make me like think I'm root. So I'm going to do that in the user namespace, and then run this command. Who am I? And it's telling me, hey, you're root. Read link is a command that'll like tell you where the link takes you to. So I'm saying, hey, what is the current shell's process ID? It is 4821 unshare I'm actually forking off. Yeah, I'm forking it off. And what command did I run? Oh, relink. Okay, for the proc that shelf, and it'll tell me that I'm PID1 after this. So I just changed what process namespace I was in. Now that process thinks that it's PID1. Questions? Okay, namespace. I got the thing for here. It'll be long and it'll be very hard to tell. So I'll just run through the stuff here. Oh, what? Sorry, I got the wrong slide. So here I'm messing around with the network namespace, and this ASCII Cinema, this video, I'm not going to show it now, but it just does what I'm going to show now, right? So normally there is just a default network namespace, and you've got like your loopback adapter and your normal like Ethernet adapter, right? So I go ahead and run, say, hey, IP netns, that's another utility that is available. Add another network namespace called T1. And boom, I got a loopback adapter in a new custom namespace. And I'm setting the state, I'm bringing it up with that command. So IP netns exec T1 tells the IP link command to run inside that T1 namespace. So you gotta like always prefix that, what namespace you wanna run in. If you wanna run in a different namespace than default. So I'm bringing that thing up. Now loopback is up. Now it's got like a IP now. Now I'm adding like a virtual Ethernet pair. vEth pairs have like two things. It's like think of it as like a wire. It's got like two endpoints. So adding a vEth pair named vEth0 and vEth1, and I am IP link set vEth1 netns T1. I'm moving the vEth0 into the T1 namespace, right? So this is what it looks like. I created two things, vEth1 and vEth0. They both were in the default namespace. I ran the hey, move it to the T1 namespace. Now vEth0 has moved. Now I'm giving these things like IP addresses and bringing them up, right? So I'm say, hey, T1, your vEth0 is 10.0.0.1, and the third line is vEth1 is 10.0.0.2, and I'm bringing up IP link set vEth0 up and IP link set vEth1 up. So I'm bringing them both up. So now I got this. Now I got like a virtual connection between virtual adapters. Now I can talk to the process that is running, or the process that is running inside this custom namespace now can get to the outside world through the default namespace, and I can also talk to processes inside that custom namespace because I got a connection now. How would you route to it? I think I don't think you need a route table entry for that.
So
because in that, huh?
what would your communication path be? So if I'm on the 192 network and I'm talking to the host machine, how can I get from that adapter into the 10 network? What is my communication path to go down into that namespace?
Yeah, that's a good question. I didn't think about that. I'll need to get back to you on it.
So I guess you'd have to write some type of proxy or something like that.
I did not have to do anything to make it work, but I did not ask myself that question of. Wait, it's not. It's if. Yeah.
Yeah, it's plugged into one, right? Now you have 20 processes doing different things, and you've got to get them all plugged effectively.
I don't know. Like that. That's a very good question. So there. I would have expected a route table entry to go from the 172 to the 10.
Yeah.
I didn't know I did not need that. But I'm able to ping it and I'm able to get to it. But it is going over virtual networks. But that I will look into that.
So you can ping the 2 from
Yeah.
192?
Yeah. In that it is crossing namespace because we had that virtual Ethernet pair. Um,
So Vish, if we look at the ASCII cinema that you recorded, we can see you do all
yeah.
that.
Yeah. It's just like 3 or 4 minutes because you know how slow I type. So but it's the same thing. So chroot. Oh, did you want to look at it? I'm good. Okay. Chroot. This is what makes you think that the root is different, and it's mainly for like distribution. I can like distribute this folder with all the Ubuntu things or with Red Hat things, and if I change my root, it's going to know where to find what. So namespaces was isolation. This is distribution, kind of. I like to think of it that way. So here, how does that work? There's a utility called chroot, and this is one of those things that was created like 30 years ago. Right? So I'm saying, hey, show me what's in my root. This is what's in my root, and what am I doing? Oh, I was in the wrong. Yeah. I was root, so I'm going into that users. Okay, so chroot, and I give it what folder should look like the root now, and then I run that command lsl, and that really tells me that lsl tells me that rootfs is your root. So all these things, they just duct tape together to make things work. Scary, but good. And then cgroups. Oh, cgroups. This thing's gonna be good. So let's watch the third one. So cgroups is what controls your resources, right? Now here I'm trying to control my CPU resources. So I got a program on that machine called math o primes that calculates numbers, all the prime numbers between these things. So here I'm using this utility called like cgcreate, and I'm creating a C group in the CPU C group called CPU limited and less CPU limited, right? And I am setting, so whenever you create them, all the CPU C groups start off with 1024 or 1024. They use this units called shares. I tried looking around. Why is this they're using shares? It looks like it's got something to do with the fact that like CPUs are smart these days, and they actually power down when they're not using, like, it's not as powerful. So they actually power down when they're not being used as much. So that's maybe why they're using another shares metric. Let me go back. I think. So here I set the CPU limited share from 1024 to 512. Now I'm executing that same program in the math primes program. I'm sending the output to null, and then you can see that it's using up all my CPUs. Even though I said my CPU shares is 512, it's using it up because nothing else needs it, right? So it's using everything up. And you can see that it uses up all the CPU. What is going on? Oh, I think I jumped. Okay, now I'm out. I'm running the same program, but in a less CPU limited, which has still got a share set at 1024. Now you'll see that, 2-to-1 ratio, 1024 and 512. That's getting reflected there, 65 and 32. Now I'm running the math prime same program again in the CPU limited in the 512 shares. Now you can see that the allocations have like adjusted, and the one in the less limited, it's still at 66, and the others have like split up the remaining in 16s. Now if I run it again, I think they're going to like 10s. So that's how C groups work.
Vish, question for you.
Yes.
So I know, like from the Docker CLI, you can when you start a container, you can specify like explicit memory limits, like in terms of like megabytes, right? Which I'm assuming down under the hood is just saying, okay, this C group only has, can only use this so many resources. So when you did this cg exec command, can you also like set explicit limits like that, or can you only set it in terms of like shares?
No, like for the CPU, it was shares. For the memory, it is megabytes.
Okay, gotcha.
Yeah, for block I/O, it is bytes. So the example is shares only for the CPU C group. Yeah. And CPU C groups is all about fairness. So isolation, distribution, fairness, namespace, chroot, and C groups.
So was the reason for that shares to basically stop the container from chewing up all the host resources?
Yeah, like if you don't want containers going rogue and
automatically use up all the host resources unless you specifically tell it to share.
if nothing else is using it, it will take it up. Like I said, like first time when I ran it in the CPU limited, it took up, it was 98%.
Right.
And then I said, I created 2 buckets. One was twice as big as the other one.
Right.
So when I ran it in the smaller one, it took up 33, and the other one took up like 66. So it depends on which bucket of the C group I'm putting it in. That bucket has 512. It's still got that. The amount of CPU available is still the same. So it's going to add up all these shares and do the math to determine how much of the CPU you're getting. So these are the C groups that are available. CPU set block I/O that can limit I/O and devices and memory. We're not going to go into all that, but that's kind of the concept of C group. I will go into, so that is containers and stuff. So let's talk about just a little bit about schedulers. So what are schedulers? Because all these fancy things that you hear about, like Kubernetes and all that, all they do is they schedule things, and we have so many things that schedule stuff. Our Linux schedules processes. Your build server, Jenkins, schedules build jobs on your build agents. So, and that's kind of exactly what Kubernetes and all these schedulers are. They know what resources and how much of them are where, and they know that these are the resources that these containers need. So they just put these containers, run these containers wherever there is enough resources on what machine. So if some machine is like running out of, using up, losing resources, it's going to like move that container to another one, right? So and Kubernetes has these like concept of pods, which to me, I'm not smart enough to like totally understand why we needed it, because pods, I'm pretty sure there's a good reason. Don't believe me. So pods is basically a collection of containers. So when I say it's a collection of containers, they create like the same namespace and like C groups, and they put like multiple containers into the same namespace in C groups, right? So you can think of it as like, oh, that the only thing is, there are two namespaces and 2 or 3 containers are sitting in that, right? But you can also do it as, you can run systemd as PID1 on your container, and systemd can like spawn off other processes, right? There are some advantages to that, but I think pods, I still need to be convinced. I'm still trying to find resources to convince myself of why did they come up with this pods idea? Because if systemd or any other init process spawns up all these child processes, they can talk. They're all in the same namespace. The other thing that C groups did that did not exist before was if your process spawns multiple childs and grandchilds, that C group set applies to every process that it spawned, right? Before, we only had like this tree. It's like, oh, what is the parent PID? What is the parent PID? You got to track it. And if like a parent dies, you got the grandparent and the child, but if the parent dies, you don't know what the tree this child belongs to. So you're gonna have to like say, I think like especially like things like Apache that just fork itself, it might be hard. So C groups will solve that problem. That is one of the main problems it solves too. That is probably the main reason why they created it, not because of containers. So that is another problem that C groups solve. Yeah, so the Docker Swarm is a scheduler for containers. The scheduler is just like which machine to run the container. It's just it is an interesting concept because they can just move your containers from machine to machine all willy-nilly. It's crazy. But you know what's crazier? I know we talked about like how long do you run containers. You remember the OpenVZ who created namespaces and stuff? They've already worked on and gotten working at a technology to move a running container, hot swap like containers from one machine to another, which just blows my mind. It's like, I thought I understood it, but now it's like, I don't need it. So I don't know, and nobody today is using it, but probably, if you think about all these like Docker Swarm and Kubernetes and all these people, the way they can differentiate themselves is density, right? How many containers can I run in a machine, right? So the more denser that they can run, they're good, right? So they can make money. So density. So and that's why like things like Helm, which is like a way to describe multiple things, are nice because once you have like your Helm chart, you can say you can go run it in AWS or like easily move it. I say easily, but never gonna happen. But move it to Azure or Docker Swarm or something. Because that thing defines all the things, processes that your whole application needs and how they talk to each other and all that. It's been codified into that document. So Docker Swarm Kubernetes is another thing that does this. Apache Mesos is like more meta. You can use Mesos to build things like Kubernetes. And Kubernetes is itself is not a platform in itself. Kubernetes is a platform to build platforms. So when somebody says we're running Kubernetes, they really mean like they're running like kops on AWS or Google GCP, like whatever they got offered, an AKS on Azure or something. So Kubernetes is, you can't just run Kubernetes. You gotta like have like almost like a distribution, like a Linux distribution. You gotta run like distributions of Kubernetes. And then AWS ECS is another scheduler. And Docker had it good with like when there weren't schedulers around, and now with the whole schedulers, others are looking good. And the Kubernetes, they use a runtime called Cryo. I think that was written by like Red Hat, and Phil mentioned it last time. They don't use container D. I think they use cryo. That's another. But it also uses run C. So under the covers, it's all run C. Questions? I'm done.